Problem 16 of the AMC 10A 2021. So it says, in the following list of numbers, the integer n appears n times in the list for all n from 1 to 200, right? So we start off the list with 1, 1. We have 2 2s, 3 3s, 4 4s, 5 5s, 6 6s, 7 7s, 8 8s, and then we go 199, 199s, 200, 200s, right? So basically, this list, like the first thing, since it's asking for the median of the numbers in this list, obviously what I'm going to try to do is I'm going to find the length of the list first, right? So we have that 200 times 200 plus 1, 200 plus 1, yeah, which is 201, over 2 is equal to, and this is equal to 20,100, right? So that's the number of terms in the sequence. So what we're looking for is we're looking for the 10,050th number, right? So here's the thing. Let's say the 10,050th number is k, right? Then what we could do is the next number would either be k plus 1, or it would just be another k, right? But regardless of this, the median is either going to be k or k plus 0.5, right? So if we just say the median is k and then check the list of answer choices, we see that no two answer choices are only 0.5 apart. So we don't need to worry about the difference between k and k plus 0.5. So we can just find k, and then after we find k, we'll go with the closest number in the list, right? So that's what we're going to do. And basically we have that k, the k, this k right here, regardless, has to be the 10,050th number, right? So now here's the thing. Let's say that this number here, this number would be the k times k plus 1 over 2 number in the list, right? Now the thing is, this number here, right, this k, we don't know if it's going to be the k times k plus 1 over 2 number, because the k's are still going to continue until we reach k plus 1, right? They can continue for the next k terms, right? But in reality, this can only be k times k plus 1 over 2 with a difference of k, right? That's how much ever we can have, a difference of k. And when we realized we already have a k squared term in there, right? So it doesn't really matter that we could have a k of error, right? It could be like k away from the actual number. But the thing is, since we have a k squared term in there, and the numbers here are so big, we don't need to worry about there being a difference of k, right? A fluctuation of k. So we can just say that this number here is also going to be about the k times k plus 1 over 2 number. So we have that k times k plus 1 over 2 is approximately 10,050, right? So let's multiply by 2 on both sides, and we get k times k plus 1 is equal to, or about equal to, 20,100, right? So now, here's what I'm thinking. Once again, we can use the exact same strategy we just used. Notice that this is equal to k squared plus k, right? But here's the thing. As k goes to like these numbers that are on like such big numbers, like around 150-ish, like 150 squared is going to be 225 times 100, right? Meanwhile, k is just going to be 150. This 150 basically means nothing in terms of increasing the number. In terms of the percentage error, it's going to be less than 1%, right? So we don't need to worry about this k term here. We just get rid of it, because since k is so big, that since k squared will be so much bigger, it's just a negligible term, right? It just doesn't matter. So k squared is going to be about 20,100, right? And now here's the thing. We need to look for a number k such that k squared is approximately 20,100, right? Well, what I do is I break up 20,100 into two parts, 201 and 100, right? So k squared is approximately the product of those two terms, which means that the k is equal to the root of 201 times 10, right? Well, what is the square root of 201, right? Well, the square root of 201, we can look for perfect squares near 201, right? Like 1, let's go through the perfect squares, right? If we go like this, I mean, let's just skip over to 100. We have 169 for 13 squared. 225 is 15 squared. Maybe we'll try 14 squared, 196. 196 is within 5 of 201, so it'll give us the best approximation, right? So root 201 is about 14, which means that k is going to be about 14 times 10, which is 140. So now we look back at these answer choices, right? And the only one that makes sense in this problem is going to be the one closest to 140, right? Maybe within 1 or 2. So the answer is 142.
That's good. Now, 2021 AMC 10A problem 17. So this is look like nice geometry problem with the trapezoid. Let's see. Let's try to draw an appropriate figure for the giving, based on the giving information. I'm thinking that BC and CD, and I think that these two bases are parallel. I would like to start with this way, A, B. Let's put this way, A, B. And I go that way, because since AD is going to be perpendicular to BD, I intend to do this way, and this is going to be also kind of not a drawn to scale, but that's okay. First thing, this is parallel, and then the secondly, I can see that AD and BD perpendicular to each other. That's good. And then BC and the length of BC and CD 43, and they are equal to each other. So, okay, we complete the first sentence. Then let's continue. Intersection of diagonal, and then let's make a diagonal. The diagonal A, C, and BD intersect at point O. Okay, that's good. So that let O be intersection, and then let's put P, the midpoint of BD. So that means this is also a 90 degree, and we see that midpoint means also this, since this is isosceles triangle, we can see that that's going to be midpoint, right? So should I say this way? Okay, I will indicate that this is midpoint P. Okay. Good. So, and then we notice that these two are also parallel, and there should be, when we see this one, there should be some look like bow tie, and there will be a similarity, and we will figure out later. So OP is 11. The length of the OP is 11, and so the length AD Okay, and then we are going to figure out the length AD. Okay, first of all, I just would like to extend this point towards that AB. And this is also 90 degree, this is also 90 degree. Okay, we have to use this 43 and 43 isosceles triangles feature. Let's put this is alpha. Let's say this is alpha. So we need to think always if there is a parallel and isosceles triangle, it is kind of here. Do you see that these two angles also are equal? So, and what do we notice that there will be another what do I call here? I'm going to make another nice isosceles triangle happening here. Then that gives you that this side also 43, right? That's a 43 and 43. These are also same. So, but we have to use the midpoint idea as well, right? Since this is parallel and this P is the midpoint. So let's see, I'm going to use this color here because this is midpoint, right? These are the same, and then parallel means this is also 43 because of the two. This is parallel and this is the bisect, and also we can say this is x and this is 2x. Then I'm going to put here x and this is also 2x. Okay, I have not used this little bow tie yet. So how do I use bow tie here? That is going to be, since this is x, this is also x. That means there is here a similarity, bow tie similarity here. Bow tie similarity is happening here. Similarity ratio is 1 to 2. So that means if this is 11, this has to be 22. So that allows me to say this is 22 plus 11, that is going to be 33. So PB, the length of the PB is going to be 33. So we notice there is a nice right triangle here, and I am going to use this right triangle to find the value of x and later just double it to reach the value of AD. Let's do that. So x squared equal to 43 square minus 33 square. Then I can go this one using difference of two square idea, a little bit avoid hard work. 43, then x squared is going to be 10 times what is the 43 times? It is going to be 76. Then x is going to be square root of 10 times 4 times 19. Then x becomes, I can take this out, 2 root 190. Then the value of AD is double of the value of AD is going to be here. I can write down here. AD is going to be double 2x, which is going to be 4 square root of 190. 90. That means I can now conclude that the value of m plus n would be 194. Okay, so that was the end of the nice geometry problem, problem 17. Okay.
Okay, on to problem 18. So we have this function which has two properties. So basically, for any two rational numbers that are positive, a and b, f of a times b is equal to f of a plus f of b. And then there's an additional property where f of p is equal to p for every prime number p, right? So what I'm going to do is I'm going to divide this problem up into two problems, right? First, I want to define f for all integers, and then I'm going to use the formula to create for the ratio of two integers, some sort of formula, right? So first, let's assume that we're trying to look for f of k, where k is an integer, right? So k is an integer. So the first thing I tried to do is maybe try a couple of the first few numbers and see if I can solve for them, right? So let's start with f of 1, right? F of 1 is the first positive integer. Well, how will we solve for f of 1? Well, maybe what I'd do is I'd try plugging in a is equal to 1 into this first formula here. Then we'd get f of b is equal to f of 1 plus f of b. So it's pretty obvious from this that f of 1 is equal to 0. Right? So next up, we could try f of 2 or f of 3, but I'm not really going to bother with f of 2 or f of 3 because we already know that f of 2 is 2 and f of 3 is 3 because f of p is p for any prime number p. So let's move on to f of 4. How would we figure out what f of 4 is? Well, 4 is equal to 2 times 2, right? So f of 4 would be equal to f of 2 times 2, right? So this would be equal to f of 2 plus f of 2, right? What is f of 2? F of 2 is 2, right? So basically what we get from this is that f of 4 is going to be equal to 2 plus 2, which is equal to 4, right? Let's move on, right? F of 5 is just going to be f of 5 is just going to be 5. Let's go f of 6, right? F of 6 is also the product of two primes, so we can also express it as f of 6 is equal to f of 2 plus f of 3, right? And that's just going to be equal to 5 because f of 2 and f of 3 are 2 and 3 respectively. Now the next non-prime we come across, f of 8, is actually interesting because it's the first number that's the product of 3 primes and not 2, right? So how will we figure out f of 8? Well, first what we could do is we could say f of 8 is equal to 2 times 2 times 2, right? Well, then maybe we could split up the 2's like this. Obviously, they're not both primes, but we can still find one of them to be prime. F of 2 is prime, which means that it's equal to 2, right? And then we have f of 2 times 2 for the other one. Well, f of 2 times 2, like we already said, f of 2 times 2 is just equal to f of 2 plus f of 2, right? So what we would get is that f of 8 is equal to 6, right? Now, I'm not sure if you noticed what happened there. Since all three 2's are the same, it might be a little bit confusing to see what exactly the relationship is. So I'm going to choose a different number with 3 prime divisors, which I'm going to choose f of 30, right? Let's try f of 30. Well, 30 is equal to 2 times 3 times 5, right? So we could break this up as f of 2 times 3 plus f of 5, right? And then the thing is, using the formula again on f of 2 times 3, we get that f of 2 times 3 is equal to f of 2 plus f of 3, right? And the thing is, there's nothing special about 30 here. We could substitute in any product of primes, right? Like, let's say we just want to look for f of p1 times p2 times p3 all the way up to p of n, right? That would just be equal to f of p of 1 plus f of p of 2 plus f of p of 3 plus dot 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 plus f of p of n, right? Right? So we basically have that, which means that this is just equal to the sum of those primes, since f of p is equal to p for every prime number. So p of 1 plus p of 2 plus p of 3 plus p of 4 plus all the way up to p of n. And notice these primes aren't necessarily distinct, right? So like, let's say we have this product of primes be 12, then we'd have it be 2, 2, and 3. There's nothing saying we can't have two primes that are the same, right? So we just have this formula right now. So this tells us that for every number that's the product of at least one prime, right? So 2 and beyond, we already said f of 1 is 0. But every single number after 1, we have a well-defined relationship for it, right? So we have that first formula, right? Now let's go on to the fraction part, right? And we now know every single relationship with any integer, right? So if we can just figure out a way to express f of m over n as the sum and difference, maybe it's like the sum and difference of some random integers like f of k plus f of j minus f of o, for example, right? If we could express it like that, then we could just figure out what these three are using this formula we created down here. And then we could like do whatever we do in the formula in order to get f of m over n. And then we'd be able to solve the problem, right? So basically, as long as we can express f of m over n in terms of integers, then we're all set, right? Well, how would we get f of m over n, right? Well, maybe what I'd try doing first is substituting in a for m over n, right? Well, if we have m over n times b, that would be equal to f of m over n plus f of b, right? Now, here's the thing. M over n is going to be the fraction, right, that we're trying to find the function of. And if we have b is an integer and m over n times b is also an integer, then we can just subtract the two and we'll get f of m over n. But the question is, even if b is an integer, how would we get m over n times b to be an integer? Well, the answer is we'll just make b equal to n, right? Because then the n's would cancel and all we're left with is m. Right? So on this part here is only just going to become f of m. So we get that f of m over n is equal to f of m minus f of n. And that's it. These two formulas combined allow us to check all of the answer choices, right? I'll just give like, I'll just do like A and B just to show you. So we have these two formulas, f of p1 times p2 times dot 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 times p of n is equal to the sum of those prime numbers up to p of n. And then we also have that f of m over n is equal to f of m minus f of n, right? So let's try figuring out, for example, f of 17 over 32, right? That would be equal to f of 17, which we know is just 17, minus f of 32. Well, what's f of 32? 32, using this formula, 32 can be expressed as 2 times 2 times 2 times 2 times 2, which means that f of 32 would be 2 plus 2 plus 2 plus 2 plus 2, which would be 10, right? So this would be 7. However, this is not less than 0. So we have to move on to the next choice. What about b, right? 11 over 16. What is f of 11 over 16? Well, that would just be equal to f of 11, which is 11, minus f of 16, which is, so we have 16 is 2 times 2 times 2 times 2. Well, 2 plus 2 plus 2 plus 2 would just give us 8, right? Which would be 3. But this is also not less than 0. So we know b is not right either. And we'll go through c. C will end up with a positive number. D will end up with a positive number. But when we look at E, look what happens. F of 25 over 11, that's equal to, well, 25 is 5 times 5, which means that f of 25 would just be 5 plus 5, which is 10. And then we're subtracting f of 11, which is 11. And that is equal to negative 1. And that is less than 0. So after checking all 4 of these, A, B, C, and D, we finally know that the answer is E. Okay, next up we have this somewhat strange function from these absolute values. And at first you might be like, but at first when I saw this problem in the competition, I felt somewhat daunted by it because you don't know whether or not this part inside the absolute values is positive or negative, right? Like if let's say the problem said find the area of the region that's expressed by x squared plus y squared is equal to 3 times x minus y in parentheses plus 3 times x plus y in the parentheses, this problem would be a piece of cake because you would just move over the equations, find the equation for the circle that it's describing, and then find the area. But the problem with this is that we don't know if this is positive and this is positive. So when I first encountered this problem, I was thinking to myself, let's divide it into cases, right? Because absolute value is basically saying, right? Absolute value in its core is just casework, right? Like, let's say that if we're trying to find the absolute value of n, if n is greater than 0, then it's just equal to n. But if n is less than or equal to 0, then it's equal to negative n, right? Well, we can just create cases like this, right? So we can create two cases, right? X minus y is greater than 0, right? Greater than or equal to 0, or x minus y is less than 0. And then for each of those two paths, right? Each of those two paths, we have either x plus y is greater than or equal to 0, or x plus y is less than 0, right? For each of those. So we have 4 different cases, right? So let's go through all 4, one at a time. So I'm going to draw in a graph. So now here's the thing. How would we determine which section of the graph shows when this is positive or negative? Well, x minus y is greater than or less than 0, right? Well, if x minus y was equal to 0, then that would just give us the equation y is equal to x. So let's draw that in. Y is equal to x. So we have that equation. And now the thing is, if we have x plus y, right, we want that to be either plus or minus 0, right, above or below 0. So if we solve that, we would get y equals negative x, right? So these 4 equations, that 2 equations, divide the graph into 4 regions. And each 4 regions are the 4 cases that we just talked about, right? In this case, up here, what would x minus y be, right? X minus y, well, let's just pick like a random point in this region, right? Let's say 1, 3. X minus y would be negative, right? So the first one would be negative, and then x plus y would be 1 plus 3, which is positive, right? So we have that in this sort of region here. X minus y is going to be negative, and x plus y is going to be positive. That's why I drew in those symbols there, just to keep that in mind, right? If we go on to this next region here, right? Let's say over here, this region, all the way to these lines, right? Then we would have that, let's pick a random point again, -3, 1, right? -3, 1, so -3 minus 1 would be -4. -3 plus 1 would be -2. So in both cases, it would be negative, right? So in this case, we would have negative, because both terms, x minus y and x plus y, they're both going to be equal to 0 in that section, right? And we go around the graph. In this case, if we pick a point like, let's say 3, 1, we get their both parts are positive. And in this case down here, we get that the first one, x minus y, is positive and x plus y is negative, right? So now we have these 4 different regions, right? So let's try to solve for each of these regions, right? So let's try to solve for this region here, right? Well, if we were in that region, both parts would be positive. So the absolute value wouldn't invert it. It would just keep it as the same. So we would have this, right? So like I said before, this is easy because it's just a circle equation, right? So if you know how to solve circle equations, x squared, this adds up to 6x, right? So let's subtract 6x on both sides. 6x, and then I'm going to add 9 to complete the square, plus y squared, and then all we have on this side left over is 9, right? So that's the equation we get. And basically what this gives us is x minus 3 squared plus y squared is equal to 3 squared. So this is just a circle of radius 3 centered at the point 3, 0, right? So let's draw that in. Here is our 3, 0 point. And now here's like the circle, right? The thing is, here's the region, right? If we draw this in. But it gets cut off right at the halfway point because it doesn't extend past here onto that part because this isn't part of the function, right? This is minus and plus, so it completely changed the function. So let's move on to this part actually now. Okay, so I'm going to create more space up, right? And let's say that the first part is negative and the second part is positive, right? Well, then if this first part is negative, then the absolute value sign would invert it. So we will get y minus x, right? Instead. So we have y minus x instead of x minus y since it's negative. And then if we combine these terms now, what we're actually going to get is we're going to get 6y, right? 6y. So now, instead, what I'm going to do is instead of this part now, we're going to have x squared plus y squared. And then we're going to subtract off 6y since this now combines to 6y. And the minus 3x and the 3x cancel. So we have minus 6y on this side. And then we add 9 to both sides again to complete the square. And now in this case, we'd get the exact same thing, but x and y are swapped, right? Instead, we'd have x squared, and then we'd have y minus 3 squared from this, right? So this is just a circle of radius 3, but now it's at the point 0, 3 instead, right? So 0, 3, and now this is why I made some space up here to draw in this. So it looks like that-ish, sort of. Not exactly perfect, but you get the point. It's just a semicircle combined with this triangle, and it's the exact same shape. So at this point, I'd probably like most of us would probably think to ourselves, this probably continues all around the graph. All three, the other two also have the same shape. But I'm just going to go around the graph just to make sure, right? Well, let's say that we're on this portion of the graph, right? On that portion of the graph, we have negative and negative, right? Which means both of them would be inverted. So in this case, this would be y minus x because it would be inverted. And this part would be negative y minus x. So what we get in this case is we have 3y minus 3y. Those two parts cancel. And then we have minus 3x minus 3x, which gives us negative 6x, right? So if we have negative 6x, we can add 6 to both sides, add 6x to both sides, then add 9 to complete the square once again, and we have y squared. So we get this equation instead when we solve, which now this is x plus 3 squared plus y squared is equal to 3 squared, right? And now this is a circle centered at the point 0, negative. No, it's the point negative 3, 0, right? Right there. So I'm going to draw in there, and it's going to intersect with the equations a little, but that's okay. So that's what it looks like, right? And we could do the same thing. I actually don't have room to draw it on this side, but if you went through it and you'd see that this is positive and this is negative, what you get is you could do the exact same thing. We have x minus y, the 3x and minus 3x cancel out, and we're just left with minus 6y. If we do the same thing, add 6y to both sides this time, this would be y squared, x squared. Then we would get a circle centered at the point 0, negative 3. Right? And I can't really draw this in, but it would be the exact same shape, right? So we have this like sort of 4-leaf clover shape, and we have to find the area of it. And what I realized is that all 4 of these, so this, like, let's say call this like shape A, B, C, D, all 4 of those shapes have the exact same area. So I'm just going to find the area of this shape, which I'm going to outline in red. So let's find the area of this shape, right? Well, that wouldn't be too hard because we know on this side, on the right side of this blue line I'm drawing in, we just have a semicircle of radius 3, and that area would just be equal to 9 pi over 2, right? We square the radius, which is 3. 3 squared is 9 times pi over 2. That gives us the area of the semicircle. And then we add on the area of the triangle, which has base 6, right? And then we have height 3, right? And the area would just be 3 times 6 over 2, which is 9. So the area of this full like yellow shape, it would just be 9 pi over 2 plus 9, right? And we multiply by 4, right, to get the area of the whole shape, and we would get 18 pi plus 36. So finally, we can go back here. This is what the area is, m plus n pi, which, and if we just add up m and n, we get 54. Okay, next it's time for a combinatorics problem. So in how many ways can the sequence 1, 2, 3, 4, 5 be rearranged so that no 3 consecutive terms are increasing and no 3 consecutive terms are decreasing? Right. So I'm just going to, the way I look at this problem, when I first look at it, it's kind of confusing because it seems at first this problem is going to be an ugly casework problem, right? Because like, let's say we put in 1 and 2 and 3 as the first 3, or like maybe 4, 3, 5. The possibilities seem like without end, right? We don't know how we're supposed to do this, right? But what I do is I'm just going to start small, right? Like we know that after the first term, the second term can either be increasing or it can be decreasing, right? That's how I first looked at it. And then I realized when we go from first to second increasing, we can't have the third term be increasing because that would break the rule. So we'd have to go back down, we'd have to decrease, and then we can't decrease again because that would make 3 consecutive terms decreasing, right? So we'd have to go back up again. And then obviously we'd have to go back down again, right? So this gives us this sort of like zigzag, right? And if we decrease first, we would get the same thing, but it's just going to be inverted, right? And now obviously there's some sort of symmetry to this. So if the first term increases, there's a 1-to-1 correspondence, right? And we can just show it this way. Let's say we have this, right? 1, 4, 2, 5, 3, right? This is a sequence that works. The way we could just do it is we could replace every number with its corresponding number. We could replace 1 with 5 and 2 with 4. So if we swap 1 with 5 and 2 with 4 in the sequence, we'd get the opposite, right? We'd get 5, 2, 4, 1, 3. So there's a 1-to-1 correspondence, right? Between increasing, decreasing, increasing, decreasing, and decreasing, increasing, decreasing, increasing. So what I'm going to do is I'm just going to solve for the number of cases in the first scenario and then multiply by 2 at the end, right? So it shouldn't be too hard, right? And of course, there isn't actually that many possibilities as shown in the answer choices. There's not that many possibilities, at most 22. So you could definitely just brute force from here on out and just like guess different numbers, like first number 1, 2, 3, 4, 5. And actually in the competition, that's what I did too. But there's actually a much more subtle way to approach this problem, right? Like we can't have 1 or 2 be the top number, right? If we have 1 be a number on like these two top numbers, then we couldn't have any number below 1 that's less than 1. That's we can't. So 1 doesn't work as one of the numbers that's on these upper 2 here, right? We can't have 2 either, right? Because if we have 2, then that would mean that the lower numbers between both of the numbers below 2, they would both have to be 1 in order for them to be less. But that doesn't make sense because we don't have 2 1s in this sequence. So we know that these two numbers up here have to be 3, 4, or 5. So we can break this down into 3 cases, 3, 4, 4, 5, and 3, 5, right? 3, 4 does not work because if we put in 3 and 4 in any like permutation, we can put 3, 4, or 4, 3. It doesn't matter. Where's the 5 going to go? We can't put it here, here, or here, right? Because otherwise that would break the rule. So we know 3, 4 is not a possibility. So we have 4, 5, and 3, 5, right? So either way, let's just work on 4, 5 first, right? So no matter which way, we have 2 ways to permute 4 and 5. We can put it as 4, 5 or 5, 4. So that's 2. And then how can we place the 3, 2, and 1 below it, right? Well, the thing is there's no way to mess up at this point, right? Because 3, 2, and 1 are all less than 4 and 5. So we can just put any permutation of 3, 2, and 1, and it would satisfy the requirements, right? So 2 times 6, right? So that works like that. And then let's try the 3, 5 scenario. Well, then we would have 2 times, right? So there's 2 ways to permute the 3 and the 5. And then we have 1, 2, and 4 left over. Well, here's the thing. We can't just randomly permute the 1, 4, and 2 like we did last time. Because if we do that, there's a chance we get this, 3, 4, right? And that doesn't work, right? Because the thing is, that 4 is greater than the 3, not less. So we see from this that the 4 can't go below the 3 at all, right? So the only place the 4 can go is on the edge where the 5 is, right here. So it's below the 5, right? So the 4 is guaranteed to be in one spot regardless. And let's say we had 5 and 3 here instead, then the 4 would have to go here. So it's only one spot for the 4 regardless. And then we're left with 1 and 2, right? 1 and 2 for each of these 2 spots, right? And since 1 and 2 are both less than 3 and 5, then we can just put them in any permutation we want, 1, 2, or 2, 1. So there's 2 ways to do that as well. So we can just add these 2 scenarios up, 12, 4, and we get 16, right? 16 is the number of ways we can increase, decrease, increase, decrease. So in order to count for all possibilities, which include decrease, increase, decrease, increase, we have to multiply that by 2. And we'll get our answer of 32.
Okay.